All right, I think I'm going to get started. Welcome, everyone. I'm delighted you're here. If you're interested in cutting edge technology, analytics, or fire, or the intersection of all of the above, you are in the right session. We are going to talk this afternoon about a new capability in Iris for Health. And we're at this stage in a very early access program. I'm going to encourage all of you to sign up for it, but I hope you'll find that this is going to be very useful for your exploration of FHIR. My name's Patrick Jamieson. I'm the product manager for Iris for Health, and I work mainly with our FHIR core. So I work a lot with interoperability, but we've had requests for customers for years to try to better deliver tools to help do analytics with FHIR data. I can't take the credit for all of this. There's been a lot of developers, engineers, sales engineers, managers that all have contributed to the IRIS FHIR SQL Builder. So I'm just basically the spokesperson for a very, very talented team of people. So here is what I plan to cover. I'm going to give a high-level overview of what FHIR analytics is. It's maybe self-explanatory, but I think it's becoming more and more important. And how does the IRIS FHIR SQL Builder smooth the way for performing analytics on FHIR data? At the end of this, I hope you'll have a good knowledge of how you can do analytics with FHIR and how you can create your own custom SQL schema from your FHIR repository. Well, there's just an enormous number of use cases, and this is just a partial sample of things like population health, managing risk in populations, reporting on quality, cost of care in public health, surveillance, especially in the age of COVID, anonymized data sets, machine learning, and many more. FHIR is becoming the default healthcare data interchange format. And as people get more and more of this data, they want to analyze it. And that's very natural. So why would you ever consider viewing FHIR as SQL? Well, although FHIR is very different in its format, clinical informaticians are very skilled at working and very knowledgeable about working with relational data. And FHIR is still, even though it is not a new standard, it's still new enough that a lot of data analysts have to learn new skills to just understand what are in FHIR resources and what are the elements, etc. So if we could take FHIR data and map it to a SQL schema, we're substantially reducing the barrier of entry for data analysts. And that's what our goal is. So let me take a step back before I really dive into this whole thing of FHIR analytics and give you a perspective of three views of FHIR. FHIR as an interchange format, and I think it's an interchange format that's growing absolutely in importance. FHIR as a data model, and FHIR as a directed graph. So why is FHIR valuable as an interchange format? Why is it rising in popularity? Well, one of the things that FHIR offers, and this is just one advantage, is that it contains frequently value sets and codings that improve semantic interoperability, something lacking in HL7 v2. So this makes it a useful standard for combining data, for example, from several EMRs. So we could know what that code set that a particular observation was coded in, and we could then ingest it and normalize it much easier. How about FHIR as a data model? Well, FHIR was meant to capture healthcare data. FHIR resources essentially capture approximately 80% of all reasonable use cases in healthcare, and there are extensions to capture the other 20%. You could look at a high level, you could think of FHIR resources as really like tables. It's very oversimplified, obviously, and the elements of FHIR as columns. But we're going to see that that's not quite in alignment with some of the issues around, for example, elements being objects themselves or elements being arrays of objects. Formally, from a computational viewpoint, really what FHIR is a complex directed graph. And so this gives you kind of a view of it. There's 146 of these resources. They have elements that have directed links between the different resources. So imagine our challenge then. How are we going to project this as any kind of a relational schema? So when we look at it at a very simplified level, we see resources linked to other resources. So here's a very simplified graph showing a FHIR patient resource, Ida Brown. And she is the subject of two observations, one on blood pressure and another on smoking status. They're obviously very different kinds of observations. She has a directed link to her practitioner, Kathleen Kohler, who also has a directed link from her resource to the organization she belongs to. So this is very typical in FHIR. When we look at that for just a single patient, though, in reality, there are hundreds of links between the patient, encounters, observations, and this graph is just basically an indication at just for one patient what this data looks like. It's a very messy problem. So if we look at resources individually, how do we represent them? Well, on the left side, you see we have a tree, and that tree includes a patient with various elements, and those elements can be other objects like meta, or it could be even an array of objects like the identifier array. And then we have a number of other elements. And this is just a partial sampling of what you'd see with a patient FHIR resource. Normally, how we ingest FHIR is through JSON. And so here you'd see on the right-hand side a JSON payload that we could load into the FHIR server. What I just want to draw your attention to is that FHIR objects often are nested JSON structures. So this is, again, going to be our challenge in terms of how we build a SQL schema. So what would you see if you look under the hood and look at the FHIR repository itself? And many of our sales engineers have taken a very deep dive of this. What you'd see are resource strings. And these resource strings are JSON, but think of what you would need to do if you were going to effectively build a relational format for this. Yes, you could use your programming skills and parse this, but it would be labor intensive for sure. So there are languages that help do this, and other vendors have taken the approach of using it. FHIRPath is a very powerful language. We support FHIRPath in our product. And you could identify every resource element and extract that data. You could build a programming model, extract that data, put it in a separate repository, and analyze this with the business intelligence tool of your choice. So this is an approach, and I come from FHIR Dev days, and I could tell you it's alive and well. What other ways can you analyze this? Well, there is an open source language called SQL on FHIR. SQL on FHIR basically is not ANSI SQL, but what it does is it tries to extend SQL with various operators like unnest to unnest those objects, or the dot operator to follow a path. And then you can then issue what looks like kind of a SQL query and be able to query a FHIR repository. Now, one problem with this, of course, is that it isn't ANSI SQL, and it's really not BI compliant. So the two leading approaches, if you want to do analytics on FHIR, are you could use SQL on FHIR, like I said, doesn't work with business intelligence tools, or you could become a FHIR programmer and use FHIRPath. You learn a little bit of a new syntax, but then you could copy that data and you can move it to a separate analytics repository, and your business intelligence tool will work just fine. Well, knowing all of that about how to do FHIR analytics, we set off a couple years ago to come up with a different vision, because we thought neither of these approaches was very appealing to our customers. What we wanted to do is create a very sophisticated projection tool that would help developers create their own SQL schema using the data in their FHIR repository. So we thought we needed to arm them with a bunch of capabilities if they were going to do this successfully. Here were our top design goals at the time. We wanted a data steward to be firmly in control of building these SQL schemas. And we envisioned that data analysts would have different use cases, meaning that there would be more than a single set of schemas that would be created. And so the idea here is that there is no one universal data model in healthcare. There are data models that are built for various use cases. And so we're going to let the users build those data models for their different use cases. We wanted it to be easy to use. So we wanted to build a GUI that would allow an analyst or a data steward to be able to make these selections and create a projection, so they wouldn't need to use or learn FHIRPath. And lastly, we wanted the ability to create multiple schemas and to share transformations between different projects. So how do you make that best SQL projection for your particular use case? What do you need to do? Well, first, I think you need to understand what is in your FHIR repository. A bunch of JSON strings doesn't help you very much. You need to really get a high-level analysis of what makes up that FHIR repository. You need then, after you understand it, to have ways to create custom mappings between various elements and columns in your SQL schema. And lastly, you need ways in which to index those columns if you want to make this performant. And that's obviously very important. So let me show you what these steps are. The first step is we're going to analyze the FHIR repository. This is going to tell us everything we need to know in terms of the counts of different resources in the repository, their elements, whether we're dealing with arrays for certain elements, etc. Then we want to display this so that you can make an intelligent selection of what you want to include in terms of resources and element counts in your SQL schema. We'll obtain then those user selections so that we then, under the hood, could generate SQL projections using FHIRPath. So this is totally transparent to you. Finally, we built the capability to do editing of these transforms because there is no way in which you will not want to do certain modifications over time. So you could basically edit the transforms and reproject at any point along the way. After you do this, you can take that JSON and you could flatten it out as SQL data. So we could see here that the ID is a column in the SQL table, and one of the values is this GUID here. The key to all of this, to do this efficiently, is really taking advantage of the capability of IRIS. IRIS is a multi-model translytical database. What this means is that it can do both transactions and analytics on the same repository. So without that capability, we would be left with the same problem that other vendors have, which is basically extracting and moving the data to a separate analytics repository. Here, you will not need to do that because you could project this data using the multi-model capabilities of IRIS, which is really ideally suited for this type of task. So at this point, I think I've given you enough context. And this, I want to say at the outset, this is pre-release functionality. Again, we're in an early access phase, but I'm going to give you a demo of this, and I think the final release will look fairly similar to what you're about to see. So I'm going to start off here, and I'm going to log into the system, and I'm going to basically build an entire new SQL schema. Well, first, I got to change my password because I'm doing this for the first time here. And let me retype this here, and we'll log in. All right, so what you're seeing here is the splash page for the FHIR SQL Builder. There are no analyses, transforms, or projections. Let's create a new set, a new repository configuration. I'll call it demo. I'll assign it to localhost. 5273 is the port. And I got to enter, obviously, some credentials. I'm going to make this admin credentials. Type in my new username and password again so that I could establish these credentials. I can save that. Now, once I've done this, it will find my FHIR repository endpoint, and I could save that. So I'm ready kind of to go. Now I want to analyze all the records in this small repository. It's only about 70,000 records. We could, in larger repositories, basically create a job and analyze it, for example, overnight. But we don't need to do that for this sample application. So I'm going to launch this analysis task, and you'll see how long this takes. It doesn't take that long for small repositories. Again, in larger repositories, we have the option of doing sampling, or we have the option of limiting the number of records that we'll analyze. But here, I'd like to get 100% of all the records so that you could see everything inside this FHIR repository. So we'll let this go for a few more seconds, and I think we should be close to the end. Okay, so we got 100% of the records analyzed now. Let's build our first new transform spec. I'm going to call this just transform 1 because it's the first one here. And I'm basing it off this analysis I just did. So I'm going to create this transform spec. Now you'll see on the left-hand side, I have all the FHIR resources that were found in the repository and their counts. So we have 115 patients, and here are the elements for those patients. You can see we have the meta element. I'm going to transform this column name from meta last updated to just last updated because I think this is a very long name. And you see the filter or the FHIR path expression for this. And I'm going to go ahead and just add that to my repository. Let's add some more information. The gender, we could show a histogram of that. So you see we have slightly more women than men in this, and I'm going to add that to the repository. I could add the disease date and time. That's obviously not going to apply to most of the patients in the repository, but let's go ahead and add that anyway. Now we have other elements that are, notice, that are complex, and we need FHIR path expressions to select them. So let's say I wanted to put the patient birthplace city. So here's the address city. I'm going to modify the name and make it Persian birthplace city. But notice we need an extension here that we're going to, first let me just show you the breakdown of the histogram. But notice we're selecting this with the FHIR path expression. Notice I didn't have to type in that expression. The same thing for state. If I wanted to project this as a column, I'm going to again modify this name. So I have person, birthplace, state. And again, I'm selecting that particular extension. So we're making good progress at putting in different elements. Let me show you that again for name. Notice there are 2 repetitions. So effectively, I have to select the name I'm interested in. Here, I'm going to change this to last name, but I'm going to select the use, the official last name. And here I'm using, again, a FHIR path expression under the hood. Same thing for the given name. I'm going to make this the first name. And again, I want to select just the official name. If I didn't do that, I could create a table that would have all the different names and their types. But I just want to project these as columns for now. Let's look at address. Well, here I could see that we have address that has just a single repetition. I could create a subtable. Instead of projecting these as columns, I could basically capture all of these as a subtable. So I'm going to take the line, the city, and the state, and I'm going to all add those as projections, creating a separate table of addresses. All right, so I got a lot of information here. I think at this stage, it would be good to create my first projection. So let's go and project this transform. I'm going to create a new projection. I'm going to base it on the FHIR repository I have demo, and I'm going to use that transform 1, and I'm going to create a new package to put these tables in, and I'm going to launch that projection. Now, immediately at this stage, I could go and query that. Of course, I have to log in first. at least the first time here. And let's see if I could get these credentials correct. Okay. System, good. And type in my password here and try to type it in correctly this time. Okay, so I'm in the management portal. I'm going to filter all those tables in the package SQL 1. And you could see I have that patient and address table. I'm going to just drag this over so I could show you what does this look like when I execute this. I could see all the columns that I have just created in the transform spec. And now they're being projected or flattened in this SQL table. So this is good. We have a effectively flattened one of the tables. Let's take a look at the address table. And again, these were the things I selected: city, line, and state. And you could see I have all of those projected. So at this stage, what I could also do, I could join these two tables together. And rather than type this all out, I've just copied it and pasted it in here. And you could see what this is going to do is join the two tables, the patient table and the address table, together, so that you can, in any projected table, you could easily develop queries going against multiple tables. So that is pretty good. So what would we do then if we want to, let's say, modify these? We want to try something a little different. Well, we could go to the edit button. We're going to edit this transform spec. And this time we would like to maybe add a few more resources. So I would like to go to the observation resource and pull in some additional data that I didn't do initially. So I'd like to get the code, and I'm going to, again, change this name to code, category code. And I'm going to add that to my projection. You could see I have mostly laboratory category observations in my system. I would also like to get the subject, because if we want to basically join this to the patient table, we're going to need that reference. So I'm going to add that to my projection. And let's take a look at the values. So I could take a look at the actual value of the observation. Again, I would change this name. This is frequently happens. Let's just change this to value quantity, and we could change this to unit, value unit, and add this to the projection. And we'll include value system here. All right. So we got a very extensive transform now. I'm going to say I'm done with that, and I'm going to basically reproject. And notice that I have the little arrow, and it says it's successfully updated the current transform spec. So at this stage, we now could go back to the management portal and do some additional operations. So let's take a look at that observation table. And you could see we've got now a good projection of the different observations for all the patients in the repository. So what else can we do with this? Well, we could, again, join the patient and observation tables if we like. So we could take that, and we could then basically join this to the patient table so that we could do an aggregate query. And effectively, we could find all the observations for patients in a given city, for example. That is virtually no problem. Now, I've been showing you how to do joins with projected tables. What if we wanted to add our own table? Here, I'm going to just go ahead and create a new table in IRIS for Health. I'm using Visual Studio Code. and I'm using SQL tools to do that. Now, what I did is I created a bunch of dummy data to effectively create a table of the social determinants of health. This is entirely fake data, but I wanted to show this because I want to show you that we could then join this data to data that we're projecting from our FHIR repository. I looked at all the keys so that they are totally aligned. So we have this. Now I'll show you in Visual Studio Code, we can basically take a look and execute queries so that we could see just that these are the patients in the system. No surprise here. But how about our table of fake data for social determinants of health? We could go over there and make another selection. Let me move this over a little bit, and I'm going to do this with the social determinants of health, make another query here. And you could see, again, we have all these patients with their education, whether homeowner status, income, etc. So let's go back. Now that we've done that, we could go back to the SQL Builder and the management portal. And now we have the social determinants of health, and we could execute this. And again, you see that data. You saw that in Visual Studio Code, but I just wanted to show it to you here. So now with that data, which is coming in from IRIS, can we link that up? Well, the answer is yes, we can. We could take the patient data and the social determinants of health table, and we could do a join on those two tables. No problem. So if I execute those, we're going to get a join that shows all of the data from both the patient table and the social determinants of health. And you could see that in the columns on the right-hand side. We have all of that data. So this is kind of like a whirlwind tour of all of the different capabilities that you could use with FHIR projections. You are not limited to just this, but the idea is that you could either take projections of FHIR data or projections of FHIR data with your own custom tables and do any kinds of queries using the two. So what I want to leave you with is a few key takeaways. First, the good news is you can do analytics on FHIR data. And you got some choices in the market. You could use SQL on FHIR. It is available in open source. The limitations, no BI tools with that. You could build an ETL pipeline using FHIRPath. If you're a programmer and you know FHIR, this is absolutely a possibility for you. But if you're not comfortable with those approaches, the SQL Builder is an excellent approach because it doesn't duplicate the data and it doesn't make you learn FHIRPath to project it. And it's highly, highly performant. The steps for using that include analysis, transformation, and projection. And you could repeat those as many times as you need. The benefits really, I think, is it's intuitive to use. It's performant, so you could do real-time analytics, where in many situations with moving data, there's going to be some kind of time lag. And it's very scalable because there's no data duplication. The key to all of this, again, is IRIS. Without it, we could not make this possible to do because of its multi-model properties. Again, I want to encourage all of you here to join the Early Access Program. You can swipe in the conference app. I believe there's a QR code that will allow you to indicate your interest. If you've forgotten it somehow, you could contact me directly via email, and I will send you information on how you can join and how you could get access to the FHIR SQL Builder. So what's next? What can you do to learn more? Well, Learning Services has created some great videos that talk about what is the FHIR SQL Builder and how to effectively project HL7 FHIR with the FHIR SQL Builder. These are great videos. I very much enjoy them, and I hope you will too. The next thing is you should connect with us. I'm the product manager. I hope you'll see around the show James Barrett. He is the engineer who's largely responsible for creating the entire back end of this system, and he'd be happy to answer your questions. We're going to both be available in the Tech Exchange tomorrow for at least part of the time, so we'd be happy to give little demos of this. So with that, I thank you very much for your time and attention, and happy to take any questions.
You mentioned at the start that you could also index these tables, and I didn't see that in the demo. I was just sort of curious how you go about that.
Yeah, yes, I'm sorry in this demo. I've done it in many other demos. There is for each element in the analysis, when you select that element, there is a box for indexing. So if you check that box, it does create an index for that particular element. Yes. Wait till the mic comes over. Just so we can get on, we want to get it on the recording.
Is that index automatically updated when new data comes from to the FHIR server?
Yeah, when okay, the index is think of it just like an index on a SQL table. You don't have to keep if you build an index, as new data comes in, it's automatically indexed. Okay, so yeah, you don't have to do that manually. It's automatic. Uh-oh. Don't let him ask a question.
Oh, thanks. So I'm not clear on the premise that the repository is anything other than transitory. If FHIR is a replacement for HL7, which is better, and that's clear, HL7 is nothing but a transitory, it's a message, it's an event like an AO8, right? You got thousands. In our case, we have millions of these things coming in per day.
Right.
So the repository, I don't understand its
yeah,
significance.
What's the purpose?
It should be just transitory, because the target or the source systems have their own way of storing patients and encounters and diagnoses. So I totally don't get it.
Okay. That's fine. FHIR is an emerging standard. Okay, so it can be used as a message interchange where you're basically just exchanging messages from one system to another. But FHIR has the concept of the ability to persist. And what's the advantage of persistence? Well, persistence allows you to do search. So let's say I have 10,000 patients in my FHIR repository. There are all kinds of searches I could do with the FHIR search syntax that can generate all of the JSON information for those patients. And I could link that too with include and rev include queries to link it to observations, organizations, etc. So you don't have to use FHIR in a persistent way, but I would say the vast majority of people that use FHIR today do persist it. We do have other customers that want to build their own FHIR facades where they don't have a FHIR repository. They're taking into a FHIR query and then just getting back a RESTful response, but their persistence layer is really the underlying database. It's not a FHIR repository. So yeah, that's a FHIR question, but I'd say the majority of people building FHIR servers do persist their data as in a FHIR repository. Yep.
So does it just work with FHIR, or do we have any similar concept for SDA? Like in health share, the persistence happens in SDA, and FHIR is just a projection there. It's not actually
Right.
a repository. So
Yes, it's a good question. This version of the SQL Builder was built for our FHIR repository on IRIS for Health. So that we're starting off slow. We haven't developed a FHIR SQL Builder for Health Shares FHIR Gateway. That will come at some time in the future.
is there any roadmap for that yet, or is it still
I think part of the early access program is really defining how to optimize and do a better job with our initial implementation of this SQL Builder, which is radically different than probably most products that we've launched in the last several years. So we want to get that right first before we start talking about roadmaps with other systems.
And one last question. So if we define profiles, and when we start defining profiles, is there a way within the SQL Builder to look at the profiles and determine the join conditions or so?
That's a good question. The good news is that our FHIR repository can consume data from that has been conformed to different profiles. So we could apply profiles to our FHIR server. That data is stored still as JSON strings, so there's no problem in using the SQL Builder with different profiles that you might want to layer on top of your FHIR server.
Thank you.
All right. Oh, we have a question over here.
Just have a question along the lines of the profiles. So, let's say I have aggregated data from multiple sources, and, maybe some of the data is DSTU2, STU3, R4. So now that the patient resource may have a bunch of different variations on it, would that still be all stored as one schema, or do you have multiple schemas to handle that?
No, our FHIR server really can only work with one version of FHIR per endpoint. Okay, so there's no mix and match there. You can't just say, oh, this endpoint can take any version of FHIR. I'm not even aware of any FHIR server that can do that. Maybe it exists, but I'm not aware of it.
Yeah, it's more about like, taking in, let's say I have a network. I'm from the Health Exchange source because we have like participants from all over the country, of course. And so we're gathering FHIR data from all different types of health systems, and then that would be coming in, and so you have to sort of aggregate. It's like the subject of aggregation of data, so that all gets into one patient unified record. Right?
Yeah, it's interesting. I don't think we could handle data from a lot of different. I mean, one of the problems I would see is that I'm not clear that would validate. We validate the schema, and having different versions of FHIR, it's not going to validate. So I think you'd get rejections.
Yeah. Thank you. Thanks.
Yes. Go. Yeah. Hey, here we got somebody who knows what they're talking about.
So this use case has come up in the past for a DSTU2 endpoint and an R4 endpoint. How do you look at that data together? And effectively what we did was we just projected two separate types of tables, either the R4 tables or the DSTU2 tables. And you can because you can have multiple endpoints in the same namespace, when you project those tables, you just join them with SQL, and then you're off to the races.
All right. Well, I think this session's at a close. Again, if there's any other questions, don't hesitate to contact me. James Barrett will be available throughout the show, and see us in the Tech Exchange and get involved in the early access program. Thank you very much for coming.